Seaweed wrack is an important source of nutrients to the coast. Wrack is seaweed that washes ashore and connects a food web from the ocean to the land. But what happens if this tasty seaweed is replaced by something else? Hi, I'm Rick DeSantiago from the Long Lab, here with McKenna and Wendy. We are investigating what happens when native seaweed wrack is replaced by an invasive species. When seaweeds like this giant kelp become dislodged, they're carried to the shore by waves. Once on the shore, they provide nutrients to the grazers who eat them. The nutrients then continue through the food web as those grazers are eaten by predators, like this bird. So, what happens when a foreign seaweed comes into the ecosystem? These are some of the questions we're interested in here in Southern California, where the invasive rockweed Sargassum horneri might be here to stay. This invasive rockweed is often spotted growing alongside kelp, and just like kelp, it also washes ashore. Since native seaweeds might not be able to beat it, we want to figure out if native grazers will eat it and allow its nutrients to continue through the food web. Back at headquarters, the crew and I are developing a method that allows us to test this in the lab and in the field.
In the lab, we can set up experiments called choice feeding assays that allow us to see if native grazers will eat the invasive seaweeds.
We are using something called agar-based fake foods. First, we collect seaweeds and freeze them at -80 Celsius for 5 days. The freezing process destroys the seaweed's reproductive parts to make sure that when we use it in the field, it can't spread. We then use a freeze dryer to dry the seaweed. A freeze dryer removes all the moisture from the seaweed without allowing it to break down. Once completely dry, we can grind it up into a fine powder. Just a few more steps, and voila! We have usable seaweed. With these agar-based fake foods, we're ready to experiment in the lab and in the field. So here's what we've seen so far. Most grazers completely avoid this invasive rockweed. If you look at those dishes on the right side made from Sargassum rockweed, they never even touched it. But then we discovered something pretty interesting. Black abalone snails eat this invasive rockweed just fine. So what does that mean? Is this invasive rockweed going to continue to provide nutrients to the food web through abalone? That's difficult to say. Black abalone are hard to find in the wild these days. These once plentiful animals are considered a delicacy and people love to eat them. In fact, they were harvested by the millions at some point. Many abalone that didn't get harvested suffered from withering foot syndrome, an infection that causes them to wither away and die. Losing black abalone might mean we lose a species that can actually eat this invasive rockweed. And this might mean it takes a lot longer for those nutrients from the seaweed to go into the food web. Let's let this be a lesson to us. When making conservation plans, protecting biodiversity and understanding the whole food web might be the key to minimizing the effects of an invasion. Because if you can't beat them, you eat them.